everyone. I hope you all are enjoying React India. So I'm Ritesh and my talk is not about GraphQL. So I'm here to talk about an application that I have been developing since more than a year. It's related to music. So first of all, some background about why I made it. So I have learned music for 5 years. I have learned classical Indian music, and when you are learning classical music, you start with harmonium. So in harmonium, you use your right hand and don't use your left hand to play anything. Now, that's where I was weak. My left hand wasn't strong enough. So after harmonium, I learned mouth organ, then shifted to synthesizer, and I realized that I still have a lot to learn. Now, I joined classes, but I realized that it's not that easy because you have to go every day, and we are lazy. We are developers, we are lazy. And second thing is that if you see a YouTube tutorial, you don't get any feedback. So it's hard to learn by just seeing YouTube tutorials. I'm pretty sure that everyone here has a friend who bought a guitar, started learning it, and then left it midway. Okay, so, and I wanted to create an app which was high on performance. I've worked on a lot of apps which need performance, like, at the load time, like time to paint, time to first meaningful paint, etc. I wanted to create an app that is high on performance after loading of that page. So that's why I started creating this. Now, some things about music. For the musicians, the music is actually a series of notes. For us developers, it's just a series of events. And one important thing about music is it defines its own speed. If you change the speed of that music is totally something else. And that's a problem with JavaScript. You can't handle that main thread blocking, etc. So there are so many instruments. I think every instrument was first made with wood. Then we created electronic versions of almost every instrument. But to make sure that they played well together, the MIDI spec was formed. Now, the difference between a MIDI file and an MP3 file is just like a difference between a Photoshop file that has the data of all the layers, and then you export it as an image, you lose all that data and you have the combined data. So that's the difference. So the MIDI defines the instruments into two categories. First are normal instruments that have duration, like piano. When you press the key, you have to wait for some time and then there's duration. But some instruments like drums don't have any duration. You hit it and then you leave it right there. So these are some knowledge that you might be needing in the future for the future slides. So that's why I told them. Now, about the project, I named the project Raga. So Raga in Hindi means a musical framework. So and the biggest reason I named it Raga was the domain name was available. So the major highlights of this app are, it can be divided into 3 sections. First is loading and parsing MIDI files, then scheduling those notes, and then the visualization sync. We will tackle this all one by one, the first being loading and parsing MIDI files. So going back to the first one. So I think we all have heard this. Most of us know this, that JavaScript is single-threaded. And loading a file is a synchronous process. What it means is that your main thread is blocked until your file is loaded. Okay, and for the user it means that your site is hanged for that amount of time. Add to it that you have to even parse that file. And if your file is big, it might take a while to get parsed and your thread to get responsive again. So the moment I executed that whole file loading and parsing in the main thread, I felt better about the government websites. My performance was even terrible than theirs. So the solution to them was web workers. Now, web workers are a separate thread provided by the browser where you can run your scripts. Now, the limitation is that you don't have access to DOM, and there are only certain kinds of data like array buffers, serialized data, and shared array buffers that you can send from main thread to web worker and vice versa. So when you try to send an object, the browser automatically first serializes it and then deserializes it, and it takes a lot of time if your file is big. So one thing you can see is that rather than loading the file in the main thread, I'm actually just passing the file path to the worker and not the whole content of that file to parse. Because if I send the whole content, it will take time to, just as I said, deserialize and serialize. So then I load the web worker I load the file in the web worker. You can use the file reader API or you can use the fetch API and then do the loading and passing part both on the main thread. Okay, so now this is the code. Now the problem with web workers or its uses is its API. It follows the observer pattern. So I generally personally don't like observer pattern because you are emitting from one place and there are a lot of subscribers to it at different places. It becomes very hard to debug. So there's a library called comlink that makes it easier. It makes it promise based. So if you're not aware of comlink and you don't understand this code, it's totally okay, because the whole agenda of this talk is not to make you understand the code but the concepts. Okay, so I put this code here because I wanted to be true to the actual code I have used in the application, and yeah, so that's it. That's what's happening in the main thread. We create a new worker and we are sending the data file, it's actually file path to the web worker. Now you can either use as I said, you can either use the file reader API or the fetch API. I just like the fetch API more, so I used it and then convert it into an array buffer. Then I wrote a parser that parses that array buffer and converts it into a JSON that the browser can actually understand. So after I send that data to the main thread, I actually show the different tracks and the different percussion instruments that are available there. In the current implementation, user can only see one track at a time on the screen, though they can play any number of tracks in the background. And you have an option to turn off specific tracks or all the tracks playing in the background. So to summarize this whole first part, use web workers for heavy tasks, and that task shouldn't depend on on the DOM, and you have access to only limited web APIs. Yeah, so I already talked about this. Now the second most important part is scheduling nodes. Now it seems like an easy thing to do, but we are talking about music here, it becomes very hard. Now the first problem is the JS timers. Now set timeouts don't execute at the exact time that we want to execute them. I mean, if they execute at that time, you are lucky. So one thing that comes in mind that can prevent this to an extent is we can move even the scheduling part to web workers. But that's one solution, but there's one other problem. So this is the JS clock. So when we do date.now, this is the time we get. This is the type of time that we get. The maximum precision that we get here is of 1 milliseconds. Okay, and if we consider an average audio hardware, it provides a sampling frequency of 44.1 kilohertz. That means that an analog audio is recorded by sampling 44.1 times per millisecond. So if the max precision that I can get is 1 millisecond, we are 44.1 times slow. And this is a huge thing for music. We can't afford that. And there's even one more problem. In case of inactive tabs, JS clocks are throttled in the background. Like when you open YouTube, you change tabs, you still hear the song, right? It will be very irritating if what was supposed to be sa re ga ma suddenly turns into sa re ga ma, right? It's like a rock music turning into, classical music, and you'll hate it first, and then since I have made it, you'll hate me then. Okay, so the one solution here is using high precision Tyne API. Now this is performance.now is a part of that. Okay, so you can see the time, it is in milliseconds, but it's not an integer. Okay, so there are a lot of digits after decimal, so you get a lot of precision here. So, but there's one problem. It's not absolute time. So I'm just talking about a lot of problems I know, but these are the problems that I faced. Okay, so why even use date.now if I have a API that can give me time and it's more precise than date.now, then why to even use date.now? The difference between this and date.now is that this is a relative time. This clock starts when you load the page. So it starts with 0. And this is good for, benchmarking, that you have T1 at the start of the function, T2 at the end of the function, and you can calculate the difference and tell how much time it took. Okay, but when you create a new instance of a worker, that time in that worker starts at that moment. So the main thread and the worker thread are not in sync when you are using this performance.now. So since it's a music app, if something is out of sync, we can't actually use it. Then the solution was to use audio context, so web audio API. Now web audio API also gives us time, and that time is also precise, that you can see. It's in seconds, but it's very precise. And one difference, a bonus that we get here is, if we had even somehow scheduled those nodes in the worker, we would have had to send that data to the main thread, because web audio API is not available in the web worker. At the end of the day, you have to play those nodes, and they will play in the web audio API. So you had to send it back to the main thread, and eventually that would lead to, a lot of lag. So since we are using, since we get precise time in audio context itself, we don't have to do that, all the data traveling from here and there. We can actually use web audio API to schedule the events and at the same time play the sounds. Okay, and all of this happens in a separate thread by default. So web audio API already runs in a separate thread. So we don't have to worry about the problems that come with the main thread. But one thing is that the code is still written in the main thread. So web audio API only gives you an API where whatever you schedule runs on a different thread, but the web audio API still remains on the main thread. It's just an API. So the thing is, I could have actually reached here, but as I said, I wanted to tell about the whole journey, that what are the things, why are some things not working? That was important too. Now let's understand how the scheduling works. Now at the top you can see the events timeline, and below you can see the scheduler. Now one thing, if you have used any music creation application like GarageBand or something, there are some common features like ability to change the tempo or increase the pitch in the mid of the song. Okay, and this approach will schedule all the events using the audio API at once. So if you change the tempo in between, what that means is that you will have to reschedule all the events again from scratch. Now at that moment, event 4 was playing when you change the tempo. Now if you have decreased the speed, that 4 will go somewhere else and you will hear a glitch, and that's not what we want. So now to solve that, what we do is we schedule in installments. Like if I make the change in the second interval, the change will only be reflected from the third interval. So there's no glitch. And how are we doing this? We are actually using the combination of set interval and the web audio together. So we are using set interval to create different intervals, and then web audio to schedule the events that are present in that interval. So this is how it looks like. I mean, there are different set intervals that get executed, but this is an ideal world scenario. Assuming that the second set interval will start after the first one has finished and it's happening in the main thread, this is an ideal world scenario. It's not going to happen actually. So as we have already discussed that set intervals and set timeouts get delayed. So this is what will happen. I mean, set intervals will get delayed, you will miss nodes in between. So the solution to that is a buffer. So what we do is, if our set interval is scheduled for time t, we schedule the events for t plus delta t. Okay, and where delta is it's our buffer. So what happens is, even after our set interval is delayed, we don't miss the nodes. Now, the extra time is actually called look ahead time, and we can manage it based, I mean, that's an optional thing that we do. So this is the second part I covered, okay, and so what we saw here is that we can't use web workers because there's no sync between the web worker clock API and the main thread clock API, and that web worker doesn't have access to web audio API. And yeah, that's it. Now we have covered two very important parts of this. Now the third most important part is visualization. So when you go and open the app, there's a section above the piano that is a visualization. So what happens is, there are actually two modes in the app. One is read mode, one is write mode. So when you load a MIDI file, you go into the read mode where the notes come from top, and as soon as they hit the piano, that piano key gets highlighted. Now, so the first thing that will come to mind is, okay, those are just divs, animated divs, right, that are coming from top to bottom. But since we are using divs, we'll still have to use those clocks and intervals to schedule. This is all happening on the main thread. This can't be, moved to web worker because you need DOMS access. So, and there are even additional problems. I mean, you can't for a moment forget about precision because it's graphic and you won't be able to see the difference even if you skip few things from between. In sound you will, but in graphic you won't. So precision isn't a problem here. But the problem is that JS timers, and we have additional problem because there is relayouting, composition and painting, all of them happening. So one thing what we can do is, we have already scheduled the events in the web audio API. What if we get a callback from there itself and then do the whole animation part? But the web audio API doesn't give any callbacks, and even if it did, all the calculations you'd have done would have been in the main threads, and you will still have to do that relayouting and composition and painting. So, and that will be same for both SVGs and divs. So the third option is Canvas. Now, Canvas is simply a drawing surface for a bitmap. Whatever you create on that, Canvas has no idea about it. It's just a collection of pixels for it. And drawing or loading something in a canvas is faster and has far more room for optimizations. But surely the implementation is harder compared to divs and SVGs, and one more problem is that the interactions are hard to code for a canvas. But in my case, I didn't had any click event or something like that on the canvas, so it was totally okay. So clocks that there's a delay. It's playing on a canvas, but the piano and the visualizer are not in sync. So this solution was actually better than others. I think a lot of you would have woken up. So this solution was better than others, but still not what we wanted. So the solution for this was Offscreen Canvas. Now the best thing about Canvas is it's scriptable. So once you have created a canvas in the DOM, you don't have to worry about relayout and anything. You can just take the reference of that canvas and use JavaScript to change the content of that canvas. You can think of it as a television. Once it's set, you can change the content of that television with just changing the data. So off-screen canvases are canvases that can be created in a separate thread, like a worker. And then you can send the content from that worker to the main thread and then render it there. And you don't need any access to the DOM for it. Okay, so what I told now is that you can create an off-screen canvas in a web worker and send it to the main thread. But what I did was actually opposite. I actually created a canvas in the main thread and transferred its control to the web worker. And then the web worker made all the modifications necessary in that canvas. So the worker didn't have to send any data back. It now has the reference to the canvas and it can just change anything, the content of it. So the API that I used is transfer control to off screen. Okay, so it returns a transferable. It's actually an array buffer that can be sent to the web worker. Now this is how it is done generally. Use the post message API, and then the second argument is the transfer list. In the worker, we just simply get the canvas. We do canvas.getContext 2D, and then you can just do anything you do with the context on the main thread. Just treat it as a simple canvas. Now, there are two types of canvas. One is 2D canvas, and then there's WebGL canvas too. So some browsers support 2D canvas and some do WebGL. WebGL ones are faster, but in my case I didn't need them. So the way it's working is that I have a main thread. I send the canvas buffer to the web worker. There's a controller that is controlling my canvas, and I initialize it at the moment I load that page. And whenever I want to play some track, I just send that track data to that separate thread. But one problem here is that when I send a huge data, there's a delta t involved because it gets that again the same problem. So I had to keep into account the delta t. Now for delta t I used date.now because, as I said, performance.now was not in sync, so creating a difference from web worker and main thread would have given a wrong time. So after this, that problem was fixed. Now both the audio and the main thread and the web worker are in sync. So yeah, this was more about how I handled all those three parts. But there are some. Now the audio is running in a separate audio thread. The piano keys are running in the main thread. The file loading part and the visualizer are running in a web worker thread. And three threads have to work in sync so that this app can work. And so the most important time is that when they start. If they start with a delay, there will be delay always. Okay, so that's what I had to take care of. And for that, we have to make sure that your main thread is always, still, even though a lot of things aren't happening on the main thread, you are sending data from the main thread. Sometimes what happens is the data doesn't even, the process of sending data doesn't get started because your main thread is blocked. So even then, we have to take care of that. Now, first thing to keep in mind was use layout effect, and use effect should be used effectively. Lesser the amount of use layout effect, it's better, because it's a synchronous process. Whatever you write inside that is synchronous, and that blocks your main thread. Avoid too many nested children. That makes coding harder, and if there are too many nested children, there's something wrong with the architecture. You might have to relook it. In case you want to pass props to far off children, prefer using context. That way only that particular child will get re-rendered when the value changes. So, fun fact about this app is that I have rewritten it from scratch 4 times before even launching it. Because every time I tried a way, it failed, and I realized that to do something else, I will have to rewrite it. So I started with actually Redux, and that was slow. Then I shifted to MoveX, and then I realized that I can do without all of them, and rewrote it again. Now, after doing all these optimizations, this is, you can see the paints happening, repaints happening. It's just the keys, and at the top, it's not, I don't know why it's not visible, it's visible here. The time that's changing, 5:14, the time that's remaining time that's changing. Only 2 things are getting repainted. And the whole canvas and everything, nothing is getting repainted. So that's a lot of improvement. But we have talked about tech. One of the biggest problem with this app was that we are using it on a, laptop, okay? And how do you actually play a song? It's not accessible. It's not easy to play a song using the keyboard, right? So the solution was add support for any MIDI device. So what you can do is you can connect any MIDI device, and then you can play it on your MIDI device, and then it will reflect here. It will connect both ways. So if you make something here, you will hear the sound from your MIDI device too. So that was done using the Web MIDI API. And then I have already told that there's read mode and write mode. So to enable learning, and as I said, my first problem was that we don't get feedback when we are actually playing something or learning something. So what happens in a read mode, when you play a MIDI file, you can actually connect your own MIDI device. You can play with it. You can change the tempo, slow it down, and play with it. Whenever you press the right key, it will reflect here. It will show you that you have clicked the right key. Whenever you play the wrong key, it will show here too. So you get a feedback that you were wrong. Now, what I plan to do in future is that it can actually tell you that you were 95% correct, you were 98% correct. So you can keep track of your learning. So I have talked a lot about this. I have been developing it for so long. It's time that you can also try it. So it's deployed here. You can go and check it out. So the first thing is, I'm really sorry if it doesn't work well on your mobile device, because I haven't optimized it for that. But I will for sure. And the source code is on GitHub. It's open source. You can go and see the whole code. So the future roadmap is better support for mobile devices, support music XML, and then support sheet music. Someone who is not aware of sheet music, you might have seen people playing in bands having a sheet in front of them, signs like dollars written over it. So that sheet music, and record music and export MIDI. It was actually present in the current version too, but I have removed it because it had some bugs. So whenever you are playing actually some song, you are connecting with a MIDI device and playing some song, you can actually record it and export it as a MIDI file. What I can do in future is that whenever you play some song, someone else can actually use that MIDI file to actually learn themselves. And improve the browser compatibility. Since I'm working on APIs that are, the latest APIs, so that's the problem with them. So yeah, the icons, they haven't been done by me. Illustrations have been done by me. And yeah, carbon.now.sh for code snippets. Thank you. You can follow me here. And if you have any questions, I'm around.
Recording was brought to you by Twilio. We allow you to integrate different means of communication such as video, chat, or SMS into your React applications. If you want to learn how you can send SMS directly from a React chat, check out this video on the right or go to our Twilio YouTube channel. And if you want to watch another React India talk, we picked one out just for you over here on the left. Thanks for watching.